This is Spare Time Repair, and this is a Teac PD-100. I featured two other Teac players on this channel and both have given me multiple problems, but maybe it'll be third time lucky with this 1986 model. This was eBay listed as a no power fault, but unlike the Sony player I looked at recently, I can faintly hear something when I turn it on and off. Possibly the laser focus servo. This is the first player I've had with membrane buttons, a sure sign of its budget line credentials, but for some reason I have a soft spot for these flashy 80s players with limited displays. Let's see if I can make it slightly less limited by at least getting it to turn on. I wasn't sure what to make of those membrane buttons to begin with, but I actually think I quite like them. They do make it look a bit more sleek. Got a bit of a tobacco smell to this one. Well, I mentioned in the intro that there's a faint noise when you turn it on and off, and I thought it might be the focusing servo. So let's try that again with the cover off. Yeah, I think it is. You can see it just moving slightly. But obviously we've got no display. Well, to be fair, I didn't try opening the drawer. But no, nothing there. I don't see any circuit protectors. I thought this might be one, but it's actually a transistor. So the mains power goes direct to the power switch via this black and white cable. Then the transformer is turned on via these blue and brown cables. We've got the AC voltage going in, and that is getting to the transformer, so the switch must be okay. So that then taps into the board here, where we have 27 volts. There's no free service manual to download for this one. I'd have to pay $17 for it, which is almost as much as I paid for the unit. So for now I'm going to persevere and try to figure it out for myself. Well, I've got 16 volts coming out of the rectifier diodes and negative 16 for these ones. So I don't think there's a problem with those. I think I'm going to have to remove this board to figure out where things are going after that. Ooh, well, these voltage regulators are getting very toasty. That's almost too hot to touch. So I'm going to power this off and unplug it. That's one of these capacitors has gone short. In fact, while it's still hot, I'm going to take a temperature reading. Well, 47 degrees Celsius. It's about 120 degrees Fahrenheit. I mean, it's not burning hot, but it's hotter than it should be, I'm sure. Well, I can't easily take this PCB out because it's soldered directly onto the transformer connections. But hopefully I can loosen it enough to flip it up. The only screw holding it in is the RCA jack. Other than that, we've just got these little plastic tabs. Well, since this was heating up so much, I'm going to remove that and put that in the tester. Well, that looks like our culprit. Could take out the other one as well. See how that compares. Are they the same? So 78M12F. This one's a 79M12F. Well, would they really both be bad, or does my tester just not detect them? Well, I don't have much experience with voltage regulators, so I just had to do a bit of research. And apparently it's not surprising that they're not recognized by my multi-tester. That's because they're treated as integrated circuits and have different characteristics to a regular transistor. So for a voltage regulator, the left-sided pin is the input, the middle is the ground, and the right is the output. So if there are any shorts between those points, that would suggest there's a fault. So between the input and the ground, it's fine. The input and the output is fine, and the ground and output is fine. Same with the other one. That doesn't mean they're good, but they passed that first test. So those rectifier diodes were outputting about 16 volts. So that's what would be going into the voltage regulator. So if we inject 16 volts into this, then we can measure the output voltage and see if it's doing anything. So for my bench power supply, I'm putting in 16 volts. If I measure across here, we've got 16. And so on the output, we have 12. So it looks like this one is good. Well, I've looked into it, and the 78M12F is a positive voltage regulator, and the 79 is a negative. So it should still output 12 volts, but negative 12. But having said that, it's expecting a negative input. So if I swap the leads over so that my positive lead is in the middle, so now I've got negative 16 going in, and coming out, I should have about negative 12. And I've got nothing. So it looks like this one is bad. So although this one was getting hotter, this seems to be the one at fault. And for those of you in the know, before you shout too loudly at the screen, I now realise that these negative voltage regulators have a different pinout to the positive ones, and my test here was therefore invalid. I do figure this out later in the video. So I'm going to refit the good voltage regulator. I've got this thermal paste that's many years old, way past its best, but hopefully it'll do the job. Still looks fine actually. And I'm wondering if I inject the board with negative 12 volts here, whether it will then come to life and prove that this is the only fault. So I've attached this yellow wire to the center pin and the purple wire to the output pin. So to get my negative voltage, I'll need to connect my positive lead to the yellow, which is the ground, my negative lead to the purple, which is the output. What could go wrong? So I've got the player plugged in, so let's switch it on. Well, either my assumption was wrong, or the voltage regulator isn't the only fault. But the other one is getting very hot again. I think I'm going to remove these capacitors just to check them out of circuit. They're stuck down, so it'll be a little bit tricky. So these are 2200 microfarad. Ooh, interesting. Yeah, the tester thinks it's a resistor. And the good one is measuring fine. Well, I don't have any of these either, so it's going to be another thing I have to order. Well, just checking the resistance across this bad capacitor, it's almost a dead short, about 3 ohms, whereas this one's in the mega ohms. So maybe the bad capacitor took out the voltage regulator, or the other way round, and maybe there are more casualties. So I'll refit the good capacitor, and it would make sense to put that here, so it's the first in line. Well, one thing I can do while I'm waiting is to try and change the belt, because that will almost certainly need to be done. I can also remove the front panel and give everything a good clean, but the tray doesn't want to push out. So in fact, it might not even have a belt. It could be gear driven. Well, one of the screws for the transport is underneath the power switch, so this front panel is going to have to come off first. Well, this is quite interesting. The bracket for the transport is completely separate. And for the rear one as well. Not sure what this separate bracket's for either. I'm having to support the PCB from underneath because that's still unattached. Well, everything's cable tied together here. If I just unscrew the power switch, then I can probably just swing this panel out of the way without having to undo all the connectors. Not ideal, but I think it'll be okay. The build quality is certainly better than the 90s Teac player I looked at. So these grommets should slide out. But it's such a tangle. But yeah, there's no belt for this. Just a big old gear under here. Oh wait, there is. I can just see it under there. So I can turn this manually. And out comes the tray. And then we've got a hook in here. So if I press down on that, it should slide out completely. Well, I've released the hook, but the gear is still grabbing it. This is a horrible thing to disassemble. But it's not going to come off because the motors are holding it in place. Oh, okay. So I forced the tray in and now it's loose, so the gear is reset. And now it should come out. Yes. But I still don't have good access to this belt. I think these 2 motor screws have to come out. Well, I think we have a new winner for the most awkward belt change. So now will the PCB come off? Yeah, I think it's just the belt that's holding it on now. Well, we still don't have much room to maneuver because the sled motor is soldered directly to the board here. And I think I've got to unscrew this gear to get the belt on. So I'm going to mark, this is brown and this is grey. Alright, so there's 2 more connectors holding the board on. In fact, there's a 3rd one under here. So with the transport finally free, we can get a better look at the belt. But to remove this gear, I first need to remove this leaf switch. That's easy enough. So now I can unscrew this and get the belt off, which actually doesn't look too bad. It was probably okay, but there was no way I was going to risk it. So this is the lever for the disc clamp. And that's controlled by the cam in this gear here. Well, here's the original belt, and I don't know whether I want to risk going that close to it. So I'm going to go with this one. So I'm going to clean up this channel first. Don't want to risk anything going wrong with this. So I think all I can do is slip the belt on there and hope that I can hook it out when it's all assembled. And while I'm here, this sled rail is really sticky. So I'm going to take that out and give that a good clean. So it's just hooked on the end slightly. Okay, now it's slipped out of this retainer. Well, I can only just get this sled rail out. Yeah, that's the stickiest rail I've ever seen. Well, this thing was not designed with servicing in mind. I'm a bit worried because this thin piece here is the only thing connecting the rack gear. If I break that, it would be a disaster. Okay, I think I've got it through. Okay, it's back. So refitting this cog, I need to make sure it goes into this post here on the disc clamp. Looks good. I should definitely clean these contacts while I'm here. Well, I'm glad I did that. It's going to put a drop of oil in the bottom of this spindle motor as well. It's going to put a little bit of silicone lubricant on the rail. There doesn't appear to be a limit switch for the sled, which is unusual. Alright, let's try and get this thing back together. Well, I've just realised I don't have enough clearance to slip that belt over the pulley, because the pulley's right up against the top plate here. So I'm going to have to loosen it off again. Okay, I think I've got enough slack there. Need to use this pin to do it, I think. Well, I can't get it in there because the disc clamp's in the way. I've got this hook, but I think it's too big. I should have put a small piece of wire underneath the belt so that I could stretch it out. I think that's what I'm going to have to do. So I've just fed this piece of wire underneath and I can pull it out. Oh, finally. Well, I think I'm actually glad that the parts won't be here until next week because I've had enough of this for now. Well, I've actually been away in Los Angeles for a week, so I feel refreshed and ready to attack this again. My parts have arrived. The voltage regulator is slightly different to the other one, but it's got the same specifications. This voltage regulator was sold as new old stock and certainly doesn't appear to have been used before. Almost forgot the thermal grease. Okay, we're plugged in. Please let there be a display. Oh, it's still dead. Well, that heatsink is still getting very hot. The new one I just put in is fine. Well, we've still got a short across this new capacitor I just put in. And I know the capacitor's okay because I checked it. So we've got a problem somewhere else. Even without the negative voltage regulator in place, this positive one's still getting really hot. And although it measures 17 volts going into it, there's nothing coming out. So maybe that's bad too, even though it tests okay out of circuit. I gave myself another break from this while I was recording another video, and I also decided to stop messing around and order 2 new voltage regulators. I also replaced that other capacitor to rule that out from being the problem. So let's get these fitted and see where we are. I was about to solder those new parts in when I noticed something that made me feel very stupid, and I can't believe I didn't notice it before. The pin out for the negative voltage regulator is different from the positive one. So you don't even need the multimeter for this. You can see visually that the center pin of the positive one is connected to ground. This pad here is where the heatsink is mounted. And if we follow that trace across, we can see that it's actually the first pin of the negative voltage regulator that's ground and not the center pin. So from the very beginning, I was testing it wrongly, and sure enough I looked online and that is the normal pinout. So before, when I was injecting the voltage into the board, I was injecting it into the wrong pads. It also means that the original negative voltage regulator is probably okay. And yes, sure enough, when I connect it properly, it outputs negative 12. I do learn something new with every single project, and I'm not going to forget this in a hurry. Okay, here we go. Was it the positive voltage regulator all along? No, we still have nothing. And it's still getting really hot. So the 14 going in. Nothing coming out. Well, again, I should have noticed this sooner, but the output pin of the positive regulator is shorted to ground. I've just removed it and the pads are still shorted. So the regulator's fine. But what is putting that short on there? Well, that output trace only goes to here. And that is this black ribbon cable that goes across to here. So a problem's going to be on this side of the board somewhere. Right, I've disconnected that ribbon cable, and of course the short has now gone. I think I found it. Over here we have a shorted capacitor. So let's remove that. Yep, that is a dead short. And it's a 220 microfarad, 16 volts. There's probably nothing wrong with this original positive voltage regulator, so I'm going to refit it. So let's see if we're finally in business. Yes. Well, that took a heck of a long time to register there was no disk. So that was a masterclass in how not to fault find. Just because your voltage regulator is getting hot, it doesn't mean there's a problem with it. Just a quick note to say that although the display looks like it's flickering here, that's just the camera, and it's actually perfectly stable. But having said that, we don't know yet that it's going to work. So let's get the tray back in and see what happens. Well, 1986 calls for some Peter Gabriel. Well, we're not done yet. I wonder if we've got bad capacitors on the transport PCB as well, because now it's not even ejecting. I just had a thought. Did I clean the lens? I can't remember. Well, I haven't checked everything, but I've checked all the main components, and I can't shake the feeling that maybe it was just a dirty lens. So I think I'm going to put it back together and see if it behaves any differently. No, I've done that, and it's still not reading the disc. In fact, it's not closing the tray again now. Well, the front panel was getting in my way a bit, so I've removed the PCB from it. Got some very chunky looking LEDs on here. So the problem seems to be that it can't focus on the disc. And that could be down to the turntable height, or the focus gain might need adjusting. This azimuth screw here might be to blame. There's a few things we can try. Well, I tried adjusting the focus gain and the focus offset and the azimuth screw, and none of it has made any difference. It spins up, but just won't read it. We appear to have a decent output from the laser. I've never seen a player hunt for a disc so much before declaring that there isn't one. So I feel something is wrong there. I'm now wondering, since I suspect this came from a smoker's home, whether some smokers got into the optics. And if that's the case, then there's probably not much I can do. But right underneath the pickup are these ventilation holes, so it is possible that the internal lenses have become clouded. I've removed the pickup just to see if there's anything else I can clean on the optics, and it does look like the photo detector at the bottom here is just clipped on with this plastic bracket. Well, those screws are obviously thread locked in place. I'm not sure any smoke residue could actually even get in there. Well, these wires are obviously so fine, it looks like these screws underneath would release all that, but do I really want to risk breaking them? I'm going to leave it. I don't think there's any value in taking that apart. And I'm not going to adjust the laser because I just don't think that's ever a good idea. I'm doing it. I'm removing the photo sensor and I'm going to give it a clean. I've got nothing to lose. Oh, well, I wasn't expecting it to be held on with a spring. Well, unsurprisingly, that looks spotless, but at least I checked. Actually, might have got this wrong. I think this might be the laser itself, and this is the photo detector with the angled mirror down there somewhere. That problem with the tray not closing only seems to kick in after a couple of minutes. Then if you turn the unit off and let it cool down, it seems to be okay again. So that does suggest a capacitor problem. So as the board heats up, then something maybe becomes unstable. So it would be wise, I think, to recap the board. And that's what I did. Every single electrolytic capacitor in the entire machine was replaced, and it made absolutely no difference to either the tray closing problem or the failure to read a disc. In desperation, and purely as a last resort, I did try adjusting the laser power, but that didn't work either. I even forked out for the service manual and carried out those adjustments, again to no avail. So with great reluctance, I have to concede defeat. I was probably due a failure, but I can't help feeling disappointed. After all that effort to get it to turn on, I really thought it would read the disc okay. I have learned some valuable lessons about fault finding and voltage regulators, but the biggest lesson of all has to be avoiding Teac players in the future. Thanks for watching, and I'll see you in the next one.